Hey guys.
Hello.
Alright, so as you might have noticed in the last couple of videos, we've been experimenting with the lenses that we've picked up. These are really inexpensive used lenses from, oh gosh, the 70s and 80s. We've been experimenting with FD lenses. The problem with an FD lens is that to work on this Canon 500D, you need to have an adapter, and that adapter has to have some corrective optics in it to set the back focus correctly. That's all very complicated. I'm not going to get into too many details. The problem is that the glass
Yeah,
in the corrective element is not very good.
it's like a bad pair of contacts.
Yeah, so it lowers the amount of light that gets into the camera, and it makes things a bit fuzzy.
I see.
So I've been looking for another solution, and I found that there's another old type of lens, the Pentax M42 standard. And I thought I would pick one up because they're super cheap on eBay, and the adapters are cheap. But the good part is it doesn't need any corrective element to work well on this camera. So we can get some of the crap out from in between the sensor and the actual optics. So let's take a close-up look at this one here. All right, so right now we're looking out of the last lens we picked up, which is the 28 to 80 millimeter FD lens, and today we're using it with an adapter that doesn't have a glass corrective element, so the background is completely out of focus. You have to be about there to get anything into focus without the corrective glass.
And that's like 6 to 8 inches from the camera, so.
Yeah, right up here, and from the end of the lens, it's actually 5 inches or so to this one. All right, so this one here is a one of the M42 style lenses, and the adapter's on it, and you can see that it indeed does not have a corrective element here. It just goes right into the Canon straight on. So the silver bit is the adapter, and the rest is the original lens. You've got a aperture adjustment ring here, which allows you to open and close that f stop 1.7 to make it a higher number there.
Cool.
Okay, and you can see through this. It's a really huge opening, right? So that's nice. And of course, this is a Canon, so that 50 millimeters becomes 80 millimeters. So this becomes a 1.7 80 millimeter lens. And I'll be shooting the rest of the episode with this lens, so we can get a good feel for what it's like. And we were saying these are really cheap on eBay. I got this for, oh gosh, $10
Nice.
the lens, and about that for the adapter. So
Cool.
worth experimenting if it helps us clean up the image quality on here and makes it easier for us to do our job. The easier it is to do the videos, the more time we have to spend on the actual projects.
Correct.
And that's what the shows are about, so it's important.
Yep.
All right, I think we're going to do a little bit of XBee stuff, and then I got some more updates for you guys after the break.
March of the XBees.
Yep. All right, let's get to it.
Okay, so we're kind of diverging today from our typical XBee tutorial stuff. Last time we saw, I believe the LED and buzzer and being able to manually and automatically control or pull information from the XBee. But I decided that because I had somewhat figured out how to use a push button to, I guess, get information from the XBees, I wanted to also use the push button to do other, like, control other things. In this case, an RC servo. So what I have here connected again is two prop BOEs, and one has the switch all wired up here and is connected to the computer. And then you'll notice that this particular prop BOE isn't connected to the computer, and that's because in order to give enough juice for the RC servo, I needed to plug the prop BOE into its wall wart power supply.
And the USB bus doesn't really give enough power to run stuff like that.
Correct. So I have the RC servo wired up appropriately. Usually it's power, ground, and a signal. And you would think that some of the colors would mean certain things, but the best way to figure that out is actually obviously just to look at the data sheet for the RC servo. So what I'm going to do here actually is show you guys the code. This is the original XBee servo code, servo code that I used, that I showed you guys way back when in order to just get it moving, period. It would go in one direction, then stop, then another direction, then stop. So on the base node, what I had to do was just get it so that the XBee knew that we were anytime the switch is pushed, we were sending out a signal. And that's it. If you look at the code, it's pretty easy. It's just if the push button is on, then do a certain state. Otherwise, the state is something else. So I wanted to go one direction, and then when the push button is pushed, have it go into the other direction. And on the remote node, this one, this required reception of the information, obviously, and actually had the meat for what those different, what the different, I guess, rotations would mean in terms of direction and how long I did it for, and so on and so forth. So I will turn on the base node, and I've already loaded all the code on, so this should already work. So you see that it automatically goes counterclockwise, and if I press the button, it goes clockwise.
Well, that's handy. So theoretically, with this sort of thing, you could control a robot remotely.
Correct. Yeah, and I think actually some of these have, like, I think because of the mounting holes on the prop BOE, you should be able to...
They're designed to fit on the Bobot there.
Right, exactly.
Yeah.
You should be able to put it on, and then that'll be really easy because then all you have to do is... Yeah. And I believe the Bobot actually has enough juice. These are 1.5s, right? So, yeah. So it should have enough juice in order to power the RC servos.
Mm-hmm.
Mm-hmm. Yep. So
awesome.
that's my little fun messing around for the day. It's actually when you first start with XBees on your own, it's the more complicated part is actually not getting the XBee to communicate. It's more figuring out on which side the code goes to send information or to receive information. So. Well,
thankfully you've explained all that to us already.
Kind of. It's okay. The code will be available. It's already up on Tumblr, so we'll put the links in for that.
Awesome. So I think that's it for XBees for today.
Okay. Sounds good. Next week we'll interface it with my heart project.
Excellent.
Mm-hmm.
All right.
Okay, so we've got a little update here on the road rack.
Orange. Straights.
I this week took the time to create the bracing that holds the LCD monitor into place. So it's actually in there now.
Mm-hmm.
And you can see a little copper tail sticking out the bottom that will be plugging into the control board, which we're going to take a look at here in a minute. But first off, let's take a look at the another angle on this. Okay, so here we have it from the view that most people will probably see it from the back side, because the whisker's going to be sitting in front of it.
Yep.
And we'll throw this on a table wherever we're at, and the mic lines will come out of the back side of it here, and we'll set the mics up on the table, and we'll be able to do some recordings for Zombie Tech and for Spin. Okay, so this is the control board that actually runs the LCD itself, and as we've mentioned before, this is Joe Grant sent this over. It's a design he was working on for a company. For what's the product name again?
Field Monitor Pro.
Yeah, so it's a USB driven LCD controller. And just sort of, I'm having to change it a little bit for my purposes, but it's basically going to sit down in there, and yeah, a little umbilical that comes down from the LCD plugs into that white socket.
White socket.
But I'll show you guys the one change that I had to make here to make this viable. Alright, so you can see on the detail on the board here that we've got these through-hole momentary switches mounted here and here. There was another one on this side for the power, but because the board is sitting so far back, we have no user access to it in that rack drawer. So I replaced the switch with this little terminal block here. So I just desoldered the switch, put that in, and what we'll be doing is running a line, 2 wires that go from this to a user switch, user accessible switch on the unit.
That's easy.
Yep. So that's it for today. We'll be back next week with another update.
Cool.
Bye.
Bye.
We post videos all the time, so don't forget to subscribe and follow us on Twitter at TYMKRS.